Right. We are going to start with question number 1 that was extracted from paper 6 November 2001 October and November session. Right. It reads, a competition involves listing in order the best 6 features of a certain car. There are 10 features to choose from, e.g. power steering, airbags, air conditioning, etc. Peter makes a list of 6 features. How many different lists could Peter make? So this is very simple. Peter wants to choose 6 features from the 10 given features. So this is a combination. From the word choose, it means that we are dealing with a combination. So it's 10 features and we are going to choose 6 features from the 10 features. I hope you are listening, class. Right, then you take your calculator, you punch 10, second function, then you punch 5 so that you get your combination, then you punch 6 equals, our answer is 210. So we can do this in 210 lists. This is our answer. Right, then we move on to part B of the question. It reads, the word mobile consists of 3 consonants, M, B, L, and 3 vowels, O, I, E. How many different arrangements? If you see this word arrangement, it means that we are now dealing with permutations, right? Of all the letters of the word mobile are possible if vowels must be next to each other. So let us put a demarcation here. Let us put our consonants on the left side. Then vowels are next to each other. It means that vowels are going to be together as one, like this. So you put vowels on the right side together as one. So what you need to do here when doing the calculations is you then need to count the number of letters, right? We have 3 letters on our left side which are M, B, and L. But since vowels are together as one, it means that O, I, E is going to be taken as a single letter. I hope you are listening. So we are going to count 1, 2, 3. Then we take this one as a single letter. You get 4. So on this left side, you write 4 factorial. Then you have to multiply by the arrangements of O, I, E. In how many ways can O, I, E arrange each other? They arrange in 3 factorial ways. So it's 4 factorial times 3 factorial. So you punch 4, second function factorial times 3, second function factorial, you get what? 144. So 144 is your answer. I hope you are listening, class. Right. Let us move on to the next question. Welcome back. We are now moving on to question number 2, extracted from May-June 2002 session, question number 5, paper 6. It reads, the digits of the number 1, 2, 2, 3, 6, 7, 8 can be rearranged to give many different 7-digit numbers. Find how many different 7-digit numbers can be made. If, number 1, there are no restrictions on the order of the digits, right? So there is a formula that we make use of, and that formula is number of elements factorial divided by number of identical elements factorial. What I'm trying to say is you can encounter or come across a situation whereby of numbers you are given letters A, B, C, D, D, D like this. Then you are being asked to rearrange, or you are being asked to find the number of arrangements that can be made without restrictions, right? So we are talking of permutations here. By the word arrangements, it means we are talking of permutations, right? So what you need to do here is you count first the total number of letters given. So 1, 2, 3, 4, 5, 6, 7, we have 7 letters, and 7 factorial is going to represent your numerator. I hope you are following class, right? But you have to then divide the numerator, right, by identical elements factorial, right, or repeated elements factorial, right? You can notice that A is appearing twice on the list, right? So it means that I'm going to divide by 2 factorial, where 2 factorial is denoting that A has been written twice. Another letter that has been repeated is D. D is written thrice. So it means that 2 factorial is going to be multiplied by 3 factorial, where 3 factorial is going to support the fact that D has been written thrice. I hope you are listening, class. So 7 factorial divided by 2 factorial times 3 factorial is your answer. And that is how you arrange. I hope you are following. How do you punch this in your calculator? You put your calculator on, then you punch your 7, right? Second function, factorial is on 4. You get your 7 factorial. Then you divide, you put open bracket. Remember, we need 2 factorial times 3 factorial. So 2, here, this is 2. Second function, factorial on 4 times 3, second function, factorial on 4. Then you close your bracket like this. Equals, it means your answer is 420. So these letters, these 7 letters, can be rearranged in 420 ways. I hope you are listening. So the concept that we have used on letters is the same concept that we need to apply on this question of numbers. How many numbers do we have? Lucky enough, the question has stated the numbers that are 7 digits, right? So it means that I'm going to write 7 factorial, which is representing the number of digits given. But 7 factorial is going to be divided by the number of identical digits factorial. So the identical digits that we have on the list, we have 2, which is appearing twice. So I'm going to divide 7 factorial by 2 factorial. But this 2 factorial is not referring to the 2 as in 2 the number, but it is referring that 2 has appeared twice. What I'm trying to say is, if the question had 1, 2, 2, 2, 6, 7, 8, like this, it means you are going to say 7 factorial divided by 3 factorial. Why? Because the 2 has appeared thrice, right? So here I'm dividing by 2 factorial, not 2 as in the number 2, but 2 as in the number of appearance of 2 on the list, which is twice. I hope you are following, class, right? So there is no number other than 2 that has been repeated, right? So let us punch this in our calculator, right? 7 second function factorial, right, divided by 2 second function factorial. You get yourself 2520 as your final answer. So I'm going to write 2520. So it means that we can arrange it in 25 to 20 ways. I hope you are following class. Right. I want you to stay tuned as we move on to part 2 of the question. Right, so we are now moving on to part 2 of the question. It reads, the digits 1, 3, 7 in any order are next to each other. Right, so what you need to do here is you place your demarcation like this. Right, and this instruction written inside the bracket in any order is very, very important. Right, so I'm going to explain the two situations. What if the examiner says 1, 3, 7 in their order are next to each other? The answer that is going to come out will be different from the answer in any order. So in any order and in their order, they produce two different answers, which I'm going to explain. So let me start with the in any order aspect. Right. So what you need to do is 1, 3 and 7, you put them on their side like this. Then I'm going to put a bracket, since 1, 3 and 7 must be next to each other. In simple terms, 1, 3 and 7 must be together. I hope you are listening. Right. Then the rest of the numbers, I'm going to write them on my left side. So the rest of the numbers, we have 2, 2. I hope you are following. Then another number that we have is 6 and 8. Those numbers are not 1, 3 and 7. You write them on their own on the left side. I hope you are listening. Right. So how do you then combine? Right. If 1, 3 and 7 are next to each other, or if 1, 3 and 7 must be together, I hope you are listening. We treat this bracket as a single number. It means 137 is going to be taken as a single number. So what I'm going to write, I'm going to start by counting the numbers on my left side. We have 4 numbers, right? But this bracket, I'm going to take it as a single number to make it 5 numbers. So I'm going to write 5 factorial, which is 4 plus 1. I hope you are listening. Then 5 factorial is going to be divided by the number of identical elements or identical digits. 2 has appeared twice. So I'm going to divide 5 factorial by 2 factorial. And I have explained that the 2, I'm not referring to the number 2, but I'm referring to the number of appearance of digit 2. I hope you are listening. So we are done on the left side. Right. Then you have to multiply the left side results. Right. By taking 137 as an independent list, which is distinct from 2268. So we are not taking 137 as an independent list and find the number of arrangements of 1, 3 and 7. Right. So 1, 3 and 7 are 3 digits. So the total number of digits is 3 factorial. But I'm not going to divide, since there is no number which is appearing twice or more. I hope you are listening, class. So if you multiply 5 over 2 factorial times 3 factorial, you are going to come out with your answer. So let us do it. 5 second function factorial divided by 2 second function factorial, close bracket, times 3 second function factorial, you get 360. So 360 is your final answer. So I'm going to write 360. I hope you are listening, class. So this is your answer in this situation. But what if the examiner writes 1, 3, 7 and inside the bracket they write in their order? What are you going to do? What is going to be the answer if the examiner writes in their order? Because in this case they said in any order. But how about if the examiner writes in their order? What will be your final answer? I want you to follow. You are going to do the same steps again. You write 2, 2, 6, 8 on your left side. Then you write 1, 3, 7 on the right side. But the question is saying in their order, right? So the first thing to do is you are going to count. We have got 4 numbers on our left. But since 1, 3, and 7 are together or next to each other, this bracket is going to be taken as a single number. So on the left side, I'm going to write 5 factorial, like what we did in the previous part. Then you divide 5 factorial by the number of identical digits. 2 is appearing twice, so I'm going to divide 5 factorial divided by 2 factorial. Here comes the difference on the right side. If 1, 3, and 7 are going to appear in their order, it means that 1, 3, and 7 are not going to shuffle, right? They are going to remain 1, 3, 7. So it means 1, 3, 7 is going to be written in only 1 factorial way. I hope you are listening. Here we wrote 3 factorial. Why? Because in any order, the examiner is saying 137 can be written as 317, or it can be written as 713, or it can be written as 371, or it can be written as 317. So we have got 6 ways, which are 3 factorial ways of shuffling 137. But this question, if it comes stating that in their order, it means 1, 3, and 7 are not going to be given a room to shuffle each other. I hope you are listening, class. Hence, 1, 3, and 7, they remain the same. So you write it in one way. That's why I have placed 1 factorial. So 5 second function factorial divided by 2 second function factorial, then you close your bracket. 1 factorial is good as 1. So your answer will be 60. So 60 will be your answer if the question comes 137 in their order. But here they said in any order. So your answer is 360. I hope you are following, class. I want you to stay tuned as we move on to part 3 of the question. Right, we are now moving on to part 3 of the question. It reads, right, how many different 7-digit numbers can be made if these 7-digit numbers are even, right? So if the 7-digit numbers are even, it is very simple, right? You have to identify the number of even digits that we have from the list of 7. How many even? Even number is a number which is exactly divisible by 2. So we have 1, 2, 3, 4. There are 4 even numbers that we have, right? So what you need to do is you write 4, then 4 you divide 4 by 7. So 4 over 7 is the proportion of even numbers from the list of 7. Then you have to multiply it with the answer that we got in part A, where 7 digits arrange each other in 25, 20 ways. So if you multiply 4 over 7 times 25, 20 ways, you'll be able to tell, right, how many 7-digit numbers can be made if these 7 digits are even. So you take your calculator, then you multiply. So 4 divided by 7 times 25, 20, you get 1440. Get 1440 like this. So your answer is 1440. Then you are home and dry. I hope you are listening, class. Right. So I want you to stay tuned as we move on to the next paper. In the previous 2 questions that we did earlier, we are putting our focus or emphasis on the permutation part, right? So I have now extracted another question from May, June 2003, paper 6, question number 5. And in this question, we are going to go deeper with the combination part, I hope you are following class. Right, it reads, a committee of 5 people is to be chosen from 6 men and 4 women. I hope you are following. Right. So let me put a demarcation here. We have 6 men. Then we have 4 women. I hope you are following class. Right. And we want to choose how many people? We want to choose 5 people. From 6 men and 4 women. I want you to follow. Let us proceed. In how many ways can this be done? Right? If there must be 3 men and 2 women on the committee, 2 marks. So it means in the committee of 5, we need 3 men and 2 women. So I'm going to choose 3 men from the 6. So you write 6 combination of 3, or 6 choose 3. Then on this boundary line, you put a multiplication sign. I hope you are listening. Then we are going to choose how many women? 2 women from the 4 women. So you write 4 combination of 2. Then you multiply the left combination and the right combination so that you get yourself your answer. So this is our calculator. You punch 6 first, then you punch second function. Combination is on 5, then you punch 5. Since we need 3, it's 6 choose 3. Multiplied by 4, second function, choose 2. You get what? 120. So it means that the committee can be chosen in 120 ways. So this is the first part of the question. I hope you are listening, class. Right, I'm now moving on to the part 2 of the question. It reads, in how many ways can this be done if there must be more men than women on the committee? Right, so still I have placed my demarcation. On the left side we have men, on the right side we have women. Right, but the question is saying more men than women. I hope you are listening, class. Right, so for more men than women is 6 combination of 5. It means of the 5 members in the committee, all the members can be men. Then on the lady side, we choose 0. So this is the first combination, but you are not yet through. So I'm going to put or so that I find another combination whereby men are more than women. Men can be more than women if we choose 4 of them. Then we multiply with the 4 combination of 1, choosing 1 lady and 4 men. Still, the number of men will be more than the number of women. Or you can choose 3 men and 2 ladies. Like this. Still, the number of men are greater than the number of women. But you cannot say 6 combination of 2. Why? Because if you say 6 combination of 2, it means you now have 2 men. The number of ladies would then surpass the number of men. So we have 3 combinations which produces more men than women. I hope you are listening. Right, so what you need to do is you multiply each and every combination. After multiplying each and every combination, you combine those 3 combinations through addition. Right, so we are going to start with the first one. 6 combination of 5. 6 combination of 5. Right, times 4 combination of 0. You get 6. So I'm going to write 6. Then or denotes plus. We move on to the next. 6 combination of 4 times 4 combination of what? Of 1. You get 60. Then you put a plus. 6 combination of 3 times 4 combination of 2, you get what? You get 120. Then after that you have to add 120 plus 60 plus 6. So your answer is 186. So it means that for men to be more than women, we can do this in 186 ways. Right? We are now moving on to the last segment of today's episode, which is part 3 of the question. It reads, if there must be 3 men and 2 women, and one particular woman refuses to be on the committee with one particular man. I hope you are listening, class. Remember, we have 6 men and 4 women. We have 6 men here, and we have 4 women. And we want to choose a committee which is made up of 5 people, right? But here comes 2 people who do not want to be in the committee together. One of the 2 people is a male figure, and the other one is a female figure. So, to make it clear, let me just suggest names. Let the male figure be represented by John, right? Let the woman figure be represented by Susan, right? So in simple terms, John is part of the 6 males, right? Or John is part of the 6 men, right? And Susan is part of the 4 women, right? Then John and Susan, they vowed that they can never work together. Why? Because they contradict each other always. When making decisions, they always fight each other. So the committee will not survive if John and Susan are going to be part of the committee together, right? So we want to find ways of selecting 5 people which does not include John and Susan in that committee. I hope you are listening, class. So let us identify the possible combinations that we can use to include either John or Susan so that they do not work together in the committee. I want you to follow, class, right? So the first thing, I want to include John in the committee, and at the same time I exclude Susan. So this is the first combination that I want to produce: inclusion of John and exclusion of Susan, right? So what I want you to notice, there is a concept that I want you to get, class, right? When it comes to inclusion and exclusions, right? Take for example, Portugal is having a match with France, a critical match with France. And the coach of Portugal has 15 players selected for that match, right? But remember, in the football field, only 11 players must be selected. I hope you are listening, right? So, of the 15 players in the Portugal team, we have CR7. We have Cristiano Ronaldo as their captain, right? And the question is now asking you to find the ways of selecting the team whereby their captain Cristiano Ronaldo must be part of the captain. So it means that CR7, the captain of the Portugal, has been guaranteed, right? Has been guaranteed a place in the team, has been guaranteed as being part of the team that is going to face France, right? So a person with automatic seat or a person with automatic selection is not chosen or is not selected. I want you to get this, class. So when choosing 11 people, it means that of the 15 players that we have, we are going to remove CR7 and you'll be left with 14 players. So we are going to choose only 10 players from the 14 players. Then this becomes your final answer. So the number of ways of selecting the Portugal team whereby Cristiano Ronaldo is part of the team is 14 combination of 10. So 14, second function, combination of 10 like this. Then you put equal sign. You get what? 1001. So it means that the Portugal team can be selected in 1001 ways where Cristiano Ronaldo is part of the team. Right. So the rule of inclusion is a person with automatic seat is not selected since the person is already in the team. Right. So a person with automatic seat must be excluded, right, from the list of players. I hope you are listening, class. Then you then select from the 14 people who are not Cristiano. Then you select the 10, so that those 10 will then add to the Cristiano Ronaldo to become a full team of 11. I hope you are following, class. Right. But how about if CR7 is facing an injury and is not able to play? Right. Maybe 15 players are already at the tournament. Whilst they are training, Cristiano Ronaldo gets injured. Right. How are we going to select the team if Cristiano Ronaldo is not going to be part of the team due to injury? What are you going to do? I hope you are listening, class. Right. So when it comes to exclusion, the same thing applies. Cristiano Ronaldo, if he is going to be excluded from the team, it means we are no longer going to choose from the 15 players, but we are going to choose from the 14 players, removing Cristiano Ronaldo. Right. Then we choose 11 from the 14. In the situation above, we chose 10 from the 14. Why? Because the 11th man, Cristiano Ronaldo, already booked a place in the team. I hope you are listening. But when it comes to this situation, we remove Cristiano from the 15 and you are left with the 14. But when you're choosing, you don't choose 10, you have to choose 11, since Cristiano is not part of the team. So this is the exclusion rule and this is the inclusion rule. I hope I have made myself clear. Right. Let us go back to the question that we are doing here. Right. John and Susan, they don't want to work together. I hope you have not forgotten. Right. So if we include John, remember the committee must have 3 men, right? Must have 3 men and 2 women. So on this side we need 3 male figures, and on this side we need 2 female figures, right? So since John is included, it means John gets an automatic seat in the committee. Hence, I'm going to remove John from the 6 men. So when choosing, I choose from the 5 men. Why? Because John is already in. I hope you are listening. Right. Then the combination, I'm going to make use of 2, not 3. Why? Because since John has been included in the committee, we just need 2 men to support John so that the number of men becomes 3. So on this side, you write 5 combination of 2. That's how you have included John. Then you have to put the multiplication sign. We move on to this side where we are going to exclude Susan. Excluding Susan, it means that this 4 is going to be subtracted by 1, which is the exclusion rule, whereby Cristiano Ronaldo was injured. So it means that we are going to choose from the 3 women, right? Then from the 3 women, we choose 2 women which are required. Why am I choosing 2 here? Because Susan is excluded. Why am I choosing 2 males here? Because for them to be 3, John was included. So it's John plus the 2 to get 3. But since Susan is not part of the committee, it is only 2. And Susan is not part of the committee. That's why we have less 4 with 1. So this is the first combination that separates John and Susan from the committee. I hope you are listening, class. But this is not only the combination that we have. We are now moving on to the next combination. And on this next combination, we want to exclude John. Then include Susan. I hope you are following, guys. I want you to get this. right? So let us exclude John and include Susan. If we exclude John, it means we are now choosing from the, we need how many? 3 men, but we are now choosing from 5. Since John is excluded, 6 minus 1, you have 5 men left to be chosen. Then from the 5 men, we choose the 3 this time around. Why? Because John is not a part of the commit. Right, then to include Susan, remember we need 2 ladies, 2 female figures. Right, so since Susan is included, Susan, now we have an automatic seat. Hence, Susan must not be chosen. So when choosing, you have to list this 4 minus Susan, and the number of ladies to be chosen are 3. And of the 3 ladies to be chosen, you just need to pick 1 lady, since Susan is the second lady already with a seat in the commit. So this is the second combination. I hope you are listening. Then, the last combination left to separate Susan and John is to choose a commit in such a way that both Susan and John must not be part of the commit. So if both Susan and John fails to get seats in the committee, it still applies as a possible combination. Why? Because if we exclude both, there is no way they are going to work together. I hope you are listening, class. Right. So, excluding John, it's 5, right? Combination of 3. Excluding Susan, we less 4 minus 1 to get 3. Then we choose 2 ladies from the 3. Where 5 combination of 3 is coming from, male figures were 6, but we want to exclude both John and Susan. So 6 minus 1, we get 5 by excluding John. Then we have to pick 3 from the 5. 4 minus 1, we have excluded Susan, so that we pick 2 from the 3. I hope you are listening, class. So we have 3 possible combinations. Let us identify them using our calculator. Right. You put it on. Right. 5 second function combination of 2 times 3 second function combination of 2, you get 30. Right. So the first result here is 30. We move on to the next. 5 second function combination of 3 times 3 second function combination of 1, you get 30 again. Then move on to the last. 5 combination of 3 times 3 combination of 2, what do you get? You get 30 again. So 30 plus 30 plus 30, remember oro means plus, you get what? 90. So the commit can be selected in 90 ways. I would like to thank you guys for having me in this lesson. Thank you for your support. My name is Innocent Mapanda, or this channel we can call it Innocent Mapanda Tutorials. My phone number is on the screen, right? Do not forget to like my video, click the subscription button below and the bell so that you don't miss new videos when posted. Permutation and combination part 2 is coming your way, so do not forget to subscribe to my channel so that as soon as the episode 2 is out, you won't miss. Till we meet again, shalom.